What if everything you've been told about laziness is wrong? What if the real reason you keep procrastinating isn't a lack of discipline, but a survival system that's been controlling your brain for millions of years? Have you ever planned to start exercising, studying, or cleaning your room, only to end up scrolling on your phone for an hour instead? You know what needs to be done, but somehow your brain keeps choosing the easier option. Most people call this laziness. Today, we'll explore the science of laziness and discover why your brain sometimes works against your best intentions. For centuries, laziness was viewed as a personality flaw. Modern neuroscience tells a very different story. Researchers now know that motivation depends on a network of brain regions, including the prefrontal cortex, anterior cingulate cortex, ACC, and the brain's dopamine system, which constantly estimate whether a task is worth the mental and physical effort. Recent neuroscience reviews describe motivation as a biological process of balancing expected reward against the cost of effort, rather than simply choosing between being hardworking or lazy. One of the world's leading neurologists studying motivation, Professor Masood Hussain of the University of Oxford, summarizes this idea well. Motivation is not simply about wanting something, it's about deciding whether the effort is worth the reward. Think of your brain as an energy-saving machine. Although it makes up only about 2% of your body weight, the human brain consumes roughly 20% of your body's total energy at rest. Because of this enormous energy demand, your brain has evolved to avoid unnecessary effort whenever possible. Whenever it sees a chance to conserve energy without immediate consequences, it often takes it. In other words, your brain wasn't designed to make life easy, it was designed to keep you alive. And that survival strategy is where the science of laziness truly begins. If your brain is designed to save energy, what actually pushes you to take action? The answer lies in a chemical messenger called dopamine. Often called the brain's reward molecule, dopamine isn't simply about pleasure. Neuroscientists now describe it as a motivation and learning signal that helps your brain decide whether an action is worth the effort. The higher the expected reward, the more likely your brain is to invest energy. But if the reward seems too small or too far away, your brain often chooses the easier option instead. This process involves a network that includes the basal ganglia, nucleus accumbens, and anterior cingulate cortex, which constantly calculate the balance between effort and reward. A 2024 review in the Annual Review of Psychology concluded that dopamine plays a central role in effort-based decision-making, helping determine whether we persist or give up when tasks become challenging. But there's another reason ordinary tasks often feel difficult. Your brain is wired for instant rewards. Notifications, short videos, and social media likes trigger quick bursts of reward, making long-term goals like studying or exercising feel less motivating. Technology doesn't cause laziness, but it can make self-control more challenging. Scientists sometimes refer to this as effort discounting, the tendency to value a reward less when it requires more work. It's one reason why putting off important tasks can feel strangely satisfying in the moment, even though it creates stress later. So if you've ever blamed yourself for being lazy, remember this: your brain isn't trying to ruin your productivity, it's doing exactly what evolution programmed it to do: save energy whenever the perceived reward doesn't outweigh the effort. The real challenge is learning how to work with your brain instead of against it. The good news is that if your brain can learn habits that reduce motivation, it can also learn habits that strengthen it. One of the most effective ways is surprisingly simple: start small. When you complete even a small task, your brain activates reward circuits and releases dopamine, reinforcing the behavior and making it easier to repeat. Neuroscientists call this positive reinforcement, and over time, it helps build habits by strengthening connections between neurons through a process known as neuroplasticity. The more often a behavior is repeated, the more automatic it becomes. Recent neuroscience reviews continue to show that repeated goal-directed actions physically reshape brain networks involved in motivation and self-control. Physical activity also has a powerful effect on motivation. Just 20 to 30 minutes of brisk walking or other moderate exercise increases blood flow to the brain and stimulates the release of dopamine, norepinephrine, and brain-derived neurotrophic factor, or BDNF, often called the brain's fertilizer because it supports the growth and survival of neurons. These changes improve attention, mood, and executive function, making it easier to begin difficult tasks. Sleep is essential too. During sleep, the prefrontal cortex recovers, restoring decision-making, self-control, and motivation. Even mild sleep deprivation can make effort feel much harder than it really is. As Professor Masood Hussain of the University of Oxford explains, motivation is not about being a lazy or hardworking person. It's about how the brain evaluates effort versus reward. When that balance changes, your behavior changes with it. So the next time you catch yourself saying, "I'm just lazy," remember that your brain is following ancient survival instincts, not trying to sabotage your success. Real productivity doesn't come from fighting your brain. It comes from understanding how it works and designing your habits to work with it. If you enjoyed this video, please give it a thumbs up and subscribe to Quelxe for more informational videos. Thanks for watching.